There's a nerve in your body that most people have never heard of. It runs from your brainstem, the most ancient and fundamental part of your brain, all the way down through your neck, through your chest, branching to your heart and lungs, continuing through your diaphragm, reaching your stomach, your liver, your pancreas, your spleen, your kidneys, and your entire intestinal tract. It is the longest nerve in the human body. It carries more information, more biological data, than any other nerve outside the spinal cord. And approximately 80% of its fibers carry information upward, from your organs to your brain, rather than downward from your brain to your organs. Your gut is talking to your brain through this nerve. Your heart is talking to your brain through this nerve. Your immune system is talking to your brain through this nerve. Your lungs are talking to your brain through this nerve. Your liver, your spleen, your kidneys, all of them sending continuous biological status reports upward through this remarkable neural highway. It is called the vagus nerve, from the Latin word for wandering, because it wanders through the body in a way that no other nerve does. And its activity level, what researchers call vagal tone, is one of the most powerful predictors of cognitive health, neuroinflammation control, stress resilience, and healthy aging that science has identified in the last 2 decades. After 50, vagal tone declines. In most adults, significantly. And the consequences of that decline reach into every mechanism we've covered in this series, from neuroinflammation to gut-brain communication, to stress regulation, to sleep quality, to social connection biology. But here is what makes this video different from most discussions of the vagus nerve. The vagus nerve, unlike most of the biological mechanisms we've discussed, is directly accessible. You can stimulate it, you can restore its tone, not through drugs, not through complex protocols, not through expensive devices, through specific practices that take as little as 60 seconds and produce measurable physiological effects within minutes of implementation. The interventions are that immediate, the effects are that real, and the downstream cognitive and anti-aging benefits, as we'll see, are among the most broadly impactful of any single intervention in this series. By the end of this video, you will understand the vagus nerve completely, and you will have a 60-second restoration practice that you can begin right now. Let's establish a precise understanding of vagal tone, because it is both more specific and more measurable than most people realize. The vagus nerve is the primary component of the parasympathetic nervous system, the branch responsible for the rest and digest state. It counterbalances the sympathetic nervous system, the fight or flight system, by promoting physiological calm, reducing heart rate, and stimulating digestion. It also activates immune regulation and supports tissue repair processes that only operate efficiently when the body is not in stress response mode. Vagal tone refers to the tonic activity of the vagus nerve, the baseline level of parasympathetic input it continuously provides to organs. High vagal tone means the nerve is continuously modulating heart rate and inflammatory signaling, keeping the body in a state of flexible regulation. Low vagal tone means this modulation is reduced. The body loses some of its capacity for flexible stress response and homeostatic regulation. The most commonly used non-invasive measure of vagal tone is heart rate variability, or HRV. The heart rate in a healthy person is not perfectly regular. It varies slightly with each breath. This variability is driven by vagal input. The nerve slows the heart during exhalation and reduces inhibition during inhalation, this producing the rhythmic variation in heart rate called respiratory sinus arrhythmia. Higher HRV reflects stronger vagal modulation. Research has established HRV as one of the most powerful physiological biomarkers in aging medicine. A meta-analysis of over 100,000 adults found that lower HRV was associated with significantly higher risk of cardiovascular disease and mortality. These associations reflect the profound biological consequences of vagal tone on the systems most critical for healthy aging. Now, let's understand what the vagus nerve actually does, beyond heart rate, that makes vagal tone so important for cognitive health. The vagus nerve carries the signal of the inflammatory reflex, the neural circuit through which the brain controls systemic inflammation. When inflammatory cytokines are detected in the bloodstream, the signal travels up to the brain's nucleus tractus solitarius. The brain responds by sending efferent signals back down to the spleen, activating macrophages that suppress the inflammatory response. This inflammatory reflex is one of the most important regulatory systems, directly relevant to neuroinflammation and healthy aging. When vagal tone is high, the reflex is efficient. Inflammatory signals are quickly detected and responded to with anti-inflammatory neural regulation. The chronic low-grade inflammation of inflammaging is partially held in check by this active vagal signaling. When vagal tone is low, the reflex is less efficient. Inflammatory signals trigger a less robust anti-inflammatory response. Systemic inflammation becomes less well-regulated, and neuroinflammation increases as a consequence, accelerating the aging process. The mechanisms driving vagal tone decline after 50 are multiple and interconnected. and understanding them reveals why our interventions are simultaneously vagal tone protectors. The first mechanism is autonomic aging, the progressive deterioration of the autonomic nervous system's regulatory precision that occurs with chronological aging. The nucleus ambiguus, the brainstem nucleus that provides primary cardiac vagal output, shows progressive neuronal loss and functional decline with age. The myelination of vagal nerve fibers declines with age through the same myelin maintenance mechanisms affected by thyroid function and CoQ10 availability. Research found that HRV, the primary measure of vagal tone, declines consistently across the adult lifespan, with the most dramatic decline after age 50. Adults in their 50s show approximately 20 to 30% lower HRV than adults in their 30s. Further significant decline occurs in the 60s and 70s. The second mechanism is chronic stress dysregulation. The autonomic nervous system exists in dynamic balance between sympathetic activation and parasympathetic regulation. Chronic stress, through sustained cortisol elevation and chronic sympathetic activation, shifts this balance persistently towards sympathetic dominance. The vagus nerve's regulatory capacity is crowded out by the chronic sympathetic overactivation that modern stress biology produces in most aging adults. This creates a vicious cycle where chronic stress reduces vagal tone, which impairs the inflammatory reflex, allowing inflammation to increase. The ashwagandha, social connection, breathing reset, and sleep protocols are simultaneously vagal tone protective interventions through the stress autonomic balance pathway. The third mechanism is physical inactivity. Aerobic fitness is one of the strongest predictors of HRV and vagal tone across the adult lifespan. The mechanism involves central autonomic adaptations, increased parasympathetic dominance through cardiac vagal remodeling, and peripheral cardiac adaptations. Your daily walking and zone 2 cardio protocols are vagal tone interventions, as well as BDNF, osteocalcin, and mitochondrial interventions. The fourth mechanism is gut dysbiosis. The gut-brain communication that flows upward through the vagus nerve is bidirectional. The quality of gut sensory signaling depends on the health of the enteroendocrine cells and the gut microbiome that stimulates them. Beneficial gut bacteria, like lactobacillus and bifidobacterium, produce short-chain fatty acids that stimulate vagal sensory neurons in the gut wall. The precision probiotic protocol is therefore a vagal tone restoration protocol, improving the quality of gut-to-brain vagal signaling. The fifth mechanism is social isolation. Research has established that social connection, through activation of the oxytocin system, directly increases vagal tone. Oxytocin receptors are present on vagal neurons, and oxytocin activation promotes the parasympathetic dominance characteristic of high vagal tone. The social isolation that reduces oxytocin consequently reduces vagal tone, connecting social biology directly to autonomic regulation. Now, let's get specific about what low vagal tone does to cognitive function, because the research here is more precise and more alarming than most people realize. The first and most directly documented cognitive consequence is impaired neuroinflammation control. As we established, the vagal inflammatory reflex is the primary neural circuit for controlling systemic inflammation. Low vagal tone means less efficient inflammatory reflex activation, and the specific consequence for the brain is reduced cholinergic anti-inflammatory signaling reaching the microglia. Research published in Brain Behavior and Immunity found that lower HRV was directly associated with higher levels of TNF-alpha and IL-6 in blood, the same cytokines whose neuroinflammatory consequences we've been addressing throughout this series. The association was independent of body mass index, medication use, and other confounders, suggesting a direct causal relationship between vagal tone and inflammatory control. For cognitive aging, this means that every point of vagal tone decline is accompanied by an increase in neuroinflammatory burden that suppresses BDNF, drives microglial priming, promotes tau hyperphosphorylation, and impairs amyloid clearance. Low vagal tone and high neuroinflammation are not independent problems. They are the same problem expressed through two different measurements. The second cognitive consequence is impaired stress response regulation and the specific cognitive impairment this produces. The prefrontal cortex, critical for executive function, decision-making, and cognitive control, is both a regulator of the autonomic nervous system and a target of its dysregulation. When vagal tone is low and sympathetic dominance is high, the prefrontal cortex receives stress signals that impair its function. Cognitive flexibility, working memory, and attentional control all deteriorate under sustained sympathetic activation. Research from Julian Thayer's group found that HRV is positively correlated with prefrontal cortex activity and executive task performance. Adults with higher HRV perform better on these tasks, reflecting the brain's dependence on vagal-mediated tone for optimal function. The third consequence is impaired sleep quality, connecting vagal tone to the sleep architecture protocol from Video 5. The transition from wakefulness to sleep requires a shift from sympathetic to parasympathetic dominance, a shift that depends on adequate vagal tone to execute efficiently. Adults with low vagal tone struggle to make this transition, showing longer sleep, onset latency, and more fragmented sleep. The magnesium glycinate, L-theanine, and apigenin protocol supports the neurochemical conditions for sleep onset. Adequate vagal tone provides the autonomic foundation that makes this transition physiologically possible. The fourth consequence is reduced heart rate variability and its direct cardiovascular cognitive implications. We established that cardiovascular health and brain health are deeply interconnected. HRV, the primary measure of vagal tone, is itself a powerful predictor of cardiovascular outcomes. Low HRV predicts arterial stiffening, atherosclerosis progression, and cardiac events. And cardiovascular aging is among the most significant drivers of cognitive decline after 50. Low vagal tone accelerates both cardiovascular and cognitive aging simultaneously, because both are consequences of reduced autonomic regulation and increased inflammatory burden from impaired vagal function. Now let's get to the most immediately actionable part of this video. The specific practices that research has confirmed can measurably increase vagal tone. The 60-second restoration practice with the strongest immediate research support is the extended exhalation breathing we introduced in video 19. Let me explain the vagal mechanism specifically, because understanding it makes the practice far more compelling. Vagal tone is increased by exhalation and decreased by inhalation. This is the basis of respiratory sinus arrhythmia. During exhalation, the diaphragm rises, intrathoracic pressure decreases, and the vagus nerve's activity increases, slowing the heart. During inhalation, the opposite occurs. The ratio of exhalation to inhalation time directly determines the balance of vagal tone across the breathing cycle. Extended exhalation breathing, specifically a 4:8 ratio, produces the maximum vagal tone activation achievable through breathing manipulation. At this ratio, the majority of each cycle is spent in the vagal activating exhalation phase. HRV increases measurably within 60 seconds of beginning. Research published in Applied Psychophysiology and Biofeedback found significant increases in HRV, directly measuring vagal tone within the first minute of practice. The 60-second practice. Breathe in through your nose for 4 counts. Slow diaphragmatic breath. Breathe out through your nose or mouth for 8 counts, twice as long as the inhalation. Repeat for 60 seconds, approximately 5 breath cycles. Notice the change in your physiological state, the reduction in tension, the slight slowing of heart rate, and the increased sense of calm. That is your vagus nerve activating in real time. This 60-second practice should be performed at several specific times throughout the day. The research suggests that frequent brief vagal activation produces cumulative tone improvements over time, similar to how brief exercise sessions accumulate cardiovascular benefits. The 5 highest impact times are upon waking to establish parasympathetic tone and before meals to improve digestive efficiency and nutrient absorption. Also, before cognitively demanding tasks to optimize focus, during any experience of stress or anxiety, and before sleep to facilitate the autonomic transition. Total time investment, 5 minutes across the day. 0 financial cost, measurable physiological benefit within 60 seconds. This is a cost-effective intervention. Additional practices include cold water face immersion. The mammalian dive reflex produces one of the most powerful acute vagal activations known. Splashing cold water on the face activates cranial nerve efferents that trigger massive vagal output, producing immediate slowing of the heart rate. Practical implementation. Splash cold water on your face for 30 seconds, particularly the forehead and cheeks. Or submerge your face for a count of 10. Humming and gargling also work. The muscles of the throat are innervated by the vagus nerve, and their activation increases parasympathetic tone. Hum a low tone for 60 seconds, placing your hand on your chest to feel the resonance. These practices are easily integrated into existing routines. Genuine laughter and social engagement activate the ventral vagal complex through the social engagement system. Laughter produces HRV increases that persist for hours. Specific nutritional support also helps. Omega-3 fatty acids, magnesium, and L-theanine have all been shown to increase HRV and promote parasympathetic dominance. The complete protocol: 60-second breathing 5 times daily, cold water splash, humming while showering, and social connection. Total new financial investment: 0. This is the most immediately effective addition to the protocol. It activates the neural pathway through which your brain controls inflammation within the first minute. 32 videos. With vagal tone, we have revealed something that I think transforms the entire architecture of the system we've built. The vagus nerve is the neural infrastructure through which your brain communicates with and regulates every organ system we've been discussing. The gut-brain axis is primarily a vagal axis. 80% of gut-to-brain communication travels through these vital sensory fibers. Precision probiotics like L. reuteri improve gut sensory signals. Vagal tone determines how effectively those signals reach and influence the brain. The inflammatory reflex is a vagal reflex. High vagal tone makes regulation more efficient, while low tone leaves inflammation less controlled. Social connection activates vagal tone through the oxytocin pathway. These practices increase parasympathetic dominance measurably in real time. The breathing reset is the most direct vagal intervention. Extended exhalation, breathing powerfully, and immediately increases your vagal tone. Sleep architecture depends on vagal tone for the parasympathetic shift. Vagal tone provides the foundation for reliable restorative sleep. Stress management reduces the sympathetic overdrive that suppresses vagal tone. Ashwagandha lowers cortisol to restore autonomic balance. The oral health protocol also connects to the vagus nerve. Reducing oral inflammation allows for more effective overall inflammatory control. The vagus nerve threads through the center of the architecture, maintaining the brain's regulatory relationship with the entire body. The 60-second breathing practice is a direct intervention on the neural circuit through which your brain controls inflammation. Begin now. Breathe in for 4 counts. Breathe out for 8 counts, 5 cycles. Notice what happens in your body. That is your vagus nerve activating. Your inflammatory reflex becoming more efficient, your prefrontal cortex shifting toward optimal function. Implement this 5 times daily, add a cold water face splash, and humming to your routine. The total investment is under 10 minutes. Next week on Neurovitality. After 50, we explore nature exposure. Research shows it produces neurological effects urban environments cannot replicate. Subscribe now and share this. Thank you for 32 videos. Stay sharp, stay activated, stay vital. I will see you next week.